Population proportion. Okay, last time we talked about two sides, both side tail. Okay, both tail. Today we talk about right tail. Okay, so right tail and left tail, two tail I'm talking about today. So first of all, right tail, using the proportion, also large sample, right? Large sample, right? All right, question. So here, the working properly, machine using the two make chips calculator does not produce more than here, more than 4% defective chips. So should be less, right? So here, more than defective chips need adjustment. Okay, if more than 4%, more than 4% should be adjusted. If less, no, don't have to, right? They say that. So to check the machine working properly, okay. So blah blah blah. That's important here. All right. So sample 200 and 14 defective chip, right? So from 400 and 200. So 14 over 400, 200 will be sample proportion. Okay, so 5% significant level. So whether or not machine does not adjustment. All right. So let me write down the information. So population proportion 4%, because 4% defective chip. I mentioned that. And Q 1 minus P 96%, right? 0.96. Sample size 200, and the P hat sample proportion 14 out of 200 here, 14 out of 200, and significant level 5%, right? They mentioned that, right? Significant level. All right. So what's the P? The proportion means here proportion about what? Defective chips in the chips produced in this machine. All right, defective chips. And P hat in the sample corresponding sample proportion. Okay, so P is proportion, population proportion, and P hat is sample proportion. All right. All right, we have 5 steps. First step, null hypothesis. Second, null hypothesis and alternative hypothesis. We should find it. So first step, they said no more than should be less than equal, right? That need to adjustment. But should be bigger than, should be adjustment need, right? Should be, they said no more than 4%, right? So should be less than equal. Okay. So this why. So this one greater means right tail. You already know, right? One more time. Differ this both tail, right? Greater right tail, less left tail. Okay, so this greater is a right tail test. Second one, what kind of distribution gonna use? So they give the condition. First of all, large sample. So before NP, because proportion always checking, NP and Q should be greater than 5 both sides. So here, yeah, A greater than 5, 192, yeah, of course greater than 5. Because both satisfy, also sample size large 30. And we use normal distribution, use hypothesis, test P. Okay, which in proportion. Okay, we're gonna use proportion, using Z value. Okay, so one more time, the information here from the previous slides, because we got the information from the problem. So determine rejection or non-rejection region. So from the significant level, they said 5%, which is 0.5 left tail. So like here, 5%. So should we check this number, right? So we can, from the textbook, the table, Z value, talking about Z value, so 1.65. So calculation, by the calculation formula, sigma square root PQ. P the given, Q already given, find it. Divide the sample size, this number, standard deviation. for z value, p hat subtract p standard deviation. P hat, they said here 0.07 and p 0.04 as standard deviation. From here we got the 2.17. so we're going to compare two value. This from the significant level, this by calculation. Okay, so decision. So z value 2.17 is greater than 165, which means about here 2.17. This one rejection. So reject area. So we should reject. Machine need adjustment. Okay, too much. Okay. So how about p value? Using p value. So whatever they given z value, change it to p value. So subtract the number from the table also. We got the 0.0150. So how about significant level? Significant level is much higher. So we said it's not this reject, right? Which means need to adjustment because more than 4% is something defective chips. Alright, do you understand? We're talking about right tail. Alright, next problem. We're talking about left tail. Okay. So only three problems. Both tail, right tail, left tail. So should be alternative hypothesis this way. Alright, problem first we'll understand. This company, so what's the claim? Oh, they mentioned the claim. Good. Claim is that what? At least 90% of order are made within 32 hours. Okay, so they claim 90% order should be between within 72 hours the mailing. Okay, and sample size 150, and we have 129 over 150 will be sample proportion. So then here, so significant level 2.5%, right? So let me write down one more time the information. P, the proportion for population 90%, because they said at least 90%, and Q subtract and sample size and sample proportion 129 over 150, 0.86, significant level 2.5%. Alright. Okay, what's the defined? The P proportion. What's the proportion meaning here? Proportion all order mailed by company within 32 hours. This proportion as a proportion, right? What order? So P hat, of course, corresponding to sample proportion. So P and population, one more time. P hat sample. Okay, the claim. What's the claim? Here the claim, right? It's claim. The claim one more time. At least 90% of orders are mailed within 32 hours. That's their claim. Alright, so we're gonna find out null hypothesis, alternative hypothesis. So null hypothesis, they said at least 90%, so which means greater than 90%. That's true. So alternative hypothesis is false, which means less than. Okay, true, false. So this one less than, so which means left tail test. Okay, left tail test. Alright, so select this distribution. So first of all, change the PQ and MP and Q more than 5, greater than 5, and the sample size larger. Alright, sample size larger. So we do normal distribution to make hypothesis P. So using Z value. Okay. So one more time the information here, and then we find the rejection region, like the same method. So significant level here. So there is a significant level 2.5%. So from the textbook, right? The Z value from textbook, we can find 1.96. Left side, this one negative sign. If you right side, positive, right? So calculation statistic using formula P, Q, and sample size as square root. So we find standard deviation first of all, and Z value P hat subtract P and standard deviation, negative 1.63. So we compared here. So 1.36, how about here, right? 1.63. So decision was 36. Sorry, this way. Okay, so should be non-rejector area, right? So it's not, do not reject. So this is bigger, right? 1.67. So do not reject because this area, this non-reject area, this reject area. Okay, the p-value also here 1.63. We change it to p-value, subtract 0.516. In here 0.245, which is what? So do not reject, right? All right. So actually, to both sides, right hand, left hand, the method is all same. Not big difference. Only difference greater, less than. So depend on alternative hypothesis, we can decide that. So calculate the same part and then make a conclusion part, decision part. We can check using z value compare and the p value compare, and we can decide. Well, answer should be must be same answer come out. If it's one of different, something wrong, right? Should be same answer come out. Okay, everybody fine? Alright. Maybe see you next time. Bye bye.